When did you receive the lightning that led you to study?
Well, I grew up in South Africa, and in South Africa we have lots of thunderstorms every afternoon in the summer. So maybe this was somehow installed in my DNA as a child, seeing the huge thunderstorms in Africa. But academically, when I came to Israel, I studied in Tel Aviv University, my undergraduate degree. I completed it. I started in South Africa. And one of my professors, Professor Zev Levine, he had also done some work on lightning thunderstorms for his PhD. So he taught us courses related to lightning. And so basically from this professor who gave us some courses on lightning and electricity, that kind of electrified me. And since then, I'm interested in lightning.
So your major or your PhD was about?
So PhD was also about lightning, but about how climate change may impact lightning in the future as globe warms. So this was basically using models, climate models, which try to simulate what will happen in the future by adding greenhouse gases to the atmosphere.
What's the conclusion?
What's the conclusions?
Yeah.
Conclusions is that thunderstorms and lightning should change in the future in a warmer climate. For every 1 degree of global warming, we can expect about a 10% increase in lightning activity around the planet.
Can you elaborate? What does it mean, 10%? 10% of what?
So,
how many thunderstorms?
Okay, good question. So, as we're sitting here now, there are approximately 1,000 or 2,000 thunderstorms active somewhere on the planet. There's always some thunderstorm somewhere.
Every second, like...
Every second, it's about 1,000 to 2,000, and there are about 50 to 100 lightning flashes every second. So all the time, there's lightning going on somewhere. Most of it is in the tropics, and most of it's over land. So over
land, not over the sea.
Right, and so, which is also a research topic, because the seas, the oceans are 70% of the planet, but there's only 10% of the lightning over the oceans.
Anything we can do to better manage lightning?
We can protect ourselves against lightning. And in fact, we've got some projects in developing countries now with India and with Africa to try to protect villages and schools with simple lightning conductors. So what was called the Franklin, from Benjamin Franklin, the Franklin rod, or the lightning rod, is just a simple metal rod on the roof of a house, connected with a wire to the ground, so you have earthing. And in Africa, because so many people are actually injured, and we don't hear about it because it's one at a time or two at a time, it's not a hurricane where 100,000 people or a tsunami are injured.
We just mentioned geoengineering techniques, and you said that you don't like to manipulate nature. Like, maybe you can elaborate?
The scientists are always hesitating to talk about geoengineering because it kind of gives an excuse to the politicians to wait and see. So if it really gets bad, we have these solutions in the drawer, the geoengineering that we can quickly do. Some of them are very kind of out of this world, literally putting mirrors in space to reflect the sunlight back to the sun.
Yeah.
So you have less energy coming in.
Or back maybe toward Mars or other planets.
Other planets, huge costs. Or to brighten clouds. The Earth has about 60% coverage of clouds, which are white. They reflect the sunlight. Maybe we can make clouds brighter. Make them whiter, they'll reflect more back to us. Or putting little particles in the upper atmosphere, which simulates kind of a volcano, which will also, we know that works. And we know naturally, say after the Pinatubo eruption in 91, the Earth cooled for about 2 or 3 years by half a degree.
So in your view, what's the solution to climate?
So I think, that's the main focus of the climate center we've set up here at Tel Aviv University that I'm leading. And I could say there are five points on the roadmap, I think, if we want to solve the problem. And each point we can speak for another 3 weeks. The first one, and the major one, is we have to really go through a transformation in the energy sector. We have to move to renewable energies. So it's not something that happens overnight, but the transition, I think, has started. And I think in the next 10 years, we're going to see major changes and moving to renewable energies. It's already cheaper to use solar and wind for energy locally for unit energy. But we now have to scale this up. We need transportation of that energy from the source to the user, storage.
And subsidized from the government.
Exactly. Regulation, storage, because we don't have sun and wind all the time. But there are solutions and startup companies working on all these things. There's been a change also in the nuclear design of reactors. We don't we're not talking about the big ones which are individually designed like in the past. In South Korea, there's a push to make modular small reactors, which can be used just for an individual farm or a town, can be transported in the oceans and installed, and are much safer than the ones before. We still have the nuclear waste, the small amount we have to deal with afterwards, but everything, there's a negative side to it. It's all basically, we have to talk about risk management. What's the better or worse thing to do? So the first thing is we have to transfer our economies to renewable energies or clean energies. The second thing is we have to convert everything that can run on electricity to electricity. So our cars, trucks, buses, maybe planes in the future on electricity, but to use the clean electricity. Today, when you plug your Tesla into the wall, you're getting the electricity coming from either coal or oil or natural gas, which is not helping us much. It does reduce the noise level in the city when you have electric car and air pollution, but it doesn't really affect the climate if you're still getting the power from fossil fuel. Not everything can use electricity, especially like shipping and aircraft. So we need synthetic fuels to work on, and the main one looks like hydrogen. So hydrogen we have in every water molecule, in the oceans too. We need energy to produce but we can use renewable energies hopefully in the future to produce hydrogen. Hydrogen can be transported, can be used in basically anything from cars to planes. The non-energy sector, mainly agriculture. All of our food, we have to feed 8 billion people on the planet. This involves fertilizers, growing, and this is a big footprint also for the climate. And we have to think how to do this more sustainably. And here too, there's some interesting developments of growing beef in the laboratory and milk. We don't need to have cows anymore, maybe in the future. So that also needs to be dealt with. So those are to reduce our inputs. On the other side, we have to increase our outputs. And this is, you're talking about, I think, carbon sequestration, sucking out the carbon dioxide from the atmosphere, either by growing trees, more trees and vegetation, or algae in the ocean, or with technologies which exist. And there's a pilot in Iceland to actually suck out the carbon dioxide and pump it in like in water, like soda water, into the ground where it becomes rock, calcium carbonate, and is therefore then millions of years. So these technologies are available, but they're just too expensive at the moment, and we need to scale them up. And I think this will happen in the next 10 years. We'll see these technologies taking off, lots of investment now in this area. So I'm actually optimistic. I think we are going to solve this problem. I think an idea is that we have till 2050 to get to net zero. We have to reduce the inputs and increase the outputs by 2050 to get to net zero, and then to continue become negative emissions, sucking more and more out of the atmosphere. We've developed an online course on climate change with, I think, 13 different professors. So from all the whole faculty. So we have someone talking about the legal aspects from the law school, someone from the economy school. We've got the science side, which I speak of. We have people talking about biodiversity, of life cycle analysis, of psychology, of denial. And this has become so popular, this course, that we have 1,000 students who take this course every year. We have to stop the registration because we can't examine them online, and more than, say, 600 students at a time. So we had 2,000 students in 2 years take this course. And talking about influence, I met one of the students at the President Herzog's house, the President of Israel, where there was a function for the President's Forum on Climate Change. And she said that course caused her to get involved in climate change and be part of it. Wow. So that's, I think, the biggest way that we can influence the professors at the university, both through education of our students, which then that goes on and they move on. We also have another project at the university where we call this Climate Ambassadors, where the students of Tel Aviv go to schools, middle schools, and teach them about climate change.
Do you consider yourself as a climate activist?
It depends how you define activist. Activist is someone, I suppose, who acts to make changes. I don't see myself as someone in the streets protesting. I'm more a scientist, activist maybe, and acting maybe through education and research to change things. So in some ways, yes, especially now with our climate center, where we're not just doing basic research, we're trying to influence the direction of both the university, the region, maybe globally, and providing some solutions that could actually be adopted. So in some ways, yes, I suppose I am a climate activist, but in the way, a more quiet climate activist, where we're going through negotiations and discussions and convincing people that this is actually an opportunity.
For what in life you feel most grateful?
I suppose most people would say the family. Wife and 3 daughters and 2 granddaughters now. No males around me at home, although I'm one of 4 brothers, so it kind of skipped a generation. So definitely, I think family, children and grandchildren.
And like, do you feel worried for the future in a way?
Well, again, I'm an optimist, so I think we're going to solve this problem. It may take
Mhm.
longer than we expect, but we have examples from the past. For example, the ozone layer, which we were destroying,
Mhm.
and that too, the scientists came with the evidence, came to the politicians, showed them the evidence, and things were outlawed. The CFCs, the freon gases, and we see recovery now of the ozone layer. That was a much smaller problem because it only involved a number of big companies like DuPont and others, and so they managed to kind of solve this and get to some agreements. It's a much bigger problem of climate change, but we have many more players. We've got many more countries, and I think we're kind of at a turning point now where all of the countries understand there's a problem, and we now have to figure out how we do this, but with still keeping our standard of living without destroying the economies of countries. And again, I think next decade, we're going to see major changes and shifts. And I think, as I say, the train's left the station. I think we're leaving the era of fossil fuels and moving into renewable energies very rapidly. But we're in this transition period, which could take 10, 20 years. But I think for my children and grandchildren, hopefully, we're going to see a better world in the future.
Do you consider Israel as a safe country to live, like climate-wise, and maybe as we talked about thunderstorms and lightning, maybe cyclones? Like I'm sure we're gonna see way more cyclones eating our shores.
So, climate-wise, the Middle East and the Mediterranean are what we call a hotspot. So the actual models show that we're going to actually warm faster here than the rest of the world. There are a number of hotspots, not only here, but
So it means more
more warming.
cyclones, more warming.
Well, not necessarily cyclones, temperature. And if we look back, at least for the last decades, it's fairly clear that the temperatures are warming in Israel, and most of the warming is in the summer when it's
Mhm.
hot. So we're getting hotter temperatures, more heat waves, longer summer, shorter winter, and actually the rainfall is decreasing, not that much at the moment, but the predictions also for decreasing rainfall in the future. But when we do get rainfall, they come more intense, and produce, say, flooding, like we saw in Tel Aviv a few years ago, where those 2 people were drowned in the elevator. So the predictions are for more intense rainfall, but less water at the end of the season,
Mhm.
and hotter summers, hotter years, and sea level rise as well, which may have less impact directly on Israel, but will have on erosion on the coastlines, like in Netanya, the raised coastline. We could expect to see, when we do have the storms, maybe more intense storms. So there definitely will be impacts on here. We can expect more heat waves here. With that come more fires, and we've seen this in Israel, more intense fires. We saw in 2010, 2016, and last year that the vegetation is just much drier when the climate warms. So if someone does light the fire, everything
Yeah.
kind of blows up, and it's much more intense, the fire, and more difficult to put it out. I think one of the biggest threats to Israel is really from outside our borders. I think we're going to see a dramatic increase in climate refugees coming from Egypt, from Jordan, Syria, other countries, because the climate is going to get so hot. There's going to be food insecurity there because of problems, also sea level rise in the Nile Delta, with the climate change, that these people are going to be looking for a place which has got food and water, and that may be us. And if we have 1 million refugees at our border, what are we going to do?
Any cooperation with NASA?
So I actually studied at NASA when I was in my PhD at Columbia University. So I was at NASA for 5 years working on climate, because NASA doesn't only do space, it does many things. One of them is climate change. And we just actually have been working with the second Israeli astronaut who went to the space station, Eitan Steva.
Mhm.
So I had an experiment on what's called the Rakia mission with Eitan Steva. And we worked with Ilan Ramon, also with NASA, 20 years ago. his research project was from Tel Aviv University, from our group. So Ilan Ramon also, he was looking at thunderstorms from space for us, imaging them with a camera, which successfully, before the accident, in the tragic accident, we got our data, luckily, before the accident occurred. And Eitan Steva, just a few weeks ago, has actually duplicated that, redone it with better equipment, also successfully imaging thunderstorms and what we call sprites. These are flashes of light which occur, big red flashes of light above the thunderstorms. And we managed again to do that. So that's our link with NASA. But a lot of the research we do that's lightning is using data from NASA. So NASA has satellites in space which are looking at thunderstorms and measuring lightning around the planet. That's how we know actually that most of the lightning is over the land in tropics, because
So
we're looking from space.
only looking from space.
Yeah.
Could satellites also help us predict earthquakes or lightning or cyclones?
So we use them. I mean, weather prediction uses satellites all the time for tracking the storms, watching the motion, where they're moving. Even lightning, we know that we can just watch every, say, 15 minutes where the lightning is, and then kind of extrapolate forward in time to give early warnings to the public of another half an hour, another hour, you're going to have thunderstorms nearby. Start to close up or take care, go inside. Earthquakes is still a kind of holy grail. I've been doing some research trying to see whether something happens before earthquakes. There's lots of evidence that things happen, but no one's predicted an earthquake yet.
In your job, what gives you the most satisfaction? It seems that you are so, excited and thrilled.
Well, I'm very,
and this is an amazing topic.
Yeah, I'm very happy that I can do things which make me excited, and people are paying me money to do this, getting a salary for that. But I suppose what makes it most excited is discovering new things. So once you do research with students and you analyze data, and you try to compare some relationships, and then the eureka moment, there's some connection here, and which nobody knew about or nobody thought you would find. So lightning activity, we can use this kind of as a pulse of the storm. And nice thing about lightning is, because it's kind of, each lightning is a radio antenna, we can measure this from very far away. We don't have to be in the storm to measure the lightning. So by putting up antennas all around the world, we're part of a network, a global network, where we have 70 universities around the world, including Tel Aviv. And with those 70 stations, we can map in real time where the lightning is anywhere on the planet.
That's amazing. Like, these kind of cooperations we need to build up, not just with lightning.
We can't do it all yourself. You have to and cooperate internationally, nationally, especially with these global projects. So you have to have cooperation to really get global data on things like thunderstorms. Even satellite projects, you've got to have really international cooperation.
Could you give an example of a moral dilemma you encountered that maybe in your work in general or in dealing with climate change?
I'm not sure about a moral dilemma. Maybe something that comes to my mind is one of the areas of our research is what we call the Schumann resonances. And we've done some work with biologists on this, where we have to do actually experiments on heart tissue from mice.
Mm-hmm.
And so you actually have to kill the mice to do the experiments. So is the research worthy of killing one-day-old mice or not? So those are it's very simple moral dilemmas of whether you'd want to use animals in scientific research, which could maybe benefit humanity or not. But most of my research doesn't involve animals, so I don't think there's too much moral issues. In fact, there's a startup company not related to us who are working simultaneously, who's found that these same frequencies from the Schumann resonances help in recovery of spinal cord injury in rats. So they see that when you put these fields, and it's all external, so magnetic fields, for just 10 minutes a day, the motor recovery of the rats is much more rapid than if you don't give them the fields at all. So there's a lot of, as in many things in research, a lot more questions than answers.
That's
we
amazing.
Discover something, it raises many more questions we have.
If there was one piece of advice you could give the younger you, what would it be?
Younger me or younger generation today?
Younger you.
Younger me. I don't know if I'm very happy with the way things have turned out. So I would do it again exactly the same. I don't think I would have changed anything.
If the younger you stepped into your laboratory, what would you tell him?
Not to be scared to ask questions. Not to, yeah, asking questions again, I think is the most important. Be inquisitive, take initiative as well. Not everything the professor knows, so maybe you have a different idea, a different direction. So taking initiative and even disagreeing with a professor is good sometimes. Maybe you've read a paper that they haven't read, you got some different ideas. So to have independent thoughts and not to just accept what people tell you, you go and check it, and again, keep asking questions.
What do you think that can help Tao students become more climate activists? You mentioned previously that it's all about awareness and learning about it. Is there, like, I mean, in regards of like peer to peer, student to student, and anything like you, how to convince, or how in a very simple way to get a student become more aware and care, like the statements that people that they will do things only if they care, right? And if they don't know, then they'll do nothing. So
Yeah, so we've spoken about education, so I think that's important to educate them. But I think leading by example is always important, both the professors to the students, but the students to their peers, showing that it's not just talking about certain things, about actually doing things, whether it's riding bicycles or taking public transport or recycling or other things. But I think the students also should think of going into careers in this area, both whether it's in scientific and engineering, in the sciences, looking for solutions, technological solutions, making solar energy more efficient, storage. So if they're scientifically inclined to choose a career in that area, if they're also on the other side of the campus, looking at policy, how we can influence the government to change regulation, putting incentives for renewables, and even things with psychology. Again, for the public, how do we nudge the public to change their ways in buying, in purchasing, their behavior, their diets? You have to do it in a way that they're going to want to change, and it's going to be, again, a win-win.
yeah.
You don't want to tell them, don't do this, don't do that. So people working in psychology also can be involved in this. People working in architecture can talk about green buildings and how we can improve our buildings.
What about maybe take this and maybe come up with some future jobs in your field? Like, could you mention a few?
So, first of all, I think climate and sustainability is really a hot topic now. And most of the big companies, because they have to fulfill various regulations, the ESGs, they need people who know about climate and environment. So they're looking for people with education. So first, again, educate yourself in the field, get a degree where you're knowledgeable about this, whether you're coming from the law school, whether you're coming from economic school, whether it's life sciences, engineering. And I think there'll be plenty of jobs in industry, whether it's for being consultants or advisors, or starting up startup companies. If you can actually look for new solutions and thinking out of the box, which is kind of part of the DNA of Israelis and students here at Tel Aviv University. But in most areas, we don't really know what jobs will be available in 10 years. And so there'll be new jobs. And I'm sure whether it's to do with renewable energies, with electric transportation, some of those jobs don't exist today. You can make the jobs. The students can make these areas exist.
Yeah, just as you mentioned, there are like interdisciplinaries. It's just like sustainable and environmental consultants, or environmental law, or environmental engineering. It's like,
yeah, I mean, then
makes sense.
just there are new markets which are developing which don't exist today, and so also the electrification of the cities so you need technical people, but there's also regulation, policy issues, legal issues. And so I'm sure there are going to be plenty of jobs in this area in the future. And there seems to be lots of money also floating around waiting to invest in this area in different. So the students can actually drive the market forward.
What's the meaning of life?
What's the meaning of life? I don't know if I have an answer for that, for the meaning of life. Supposed to be happy is the meaning of life, to be happy, which could be from starting with family, but enjoying your work, doing something that you enjoy. So again, my recommendation to all of my students, they always say, well, when they come in to study first year in geophysics, they always ask, well, what's the job opportunity afterwards? Are there jobs in this field? Should I study physics or maybe study engineering? Because engineering, there's always work. And I keep telling them that if you do something you love, then you'll be good at it and you'll always find a job. It doesn't matter what. You don't want to be stuck in a job earning good money that you don't enjoy and not enjoying life. So life's too short to kind of waste the time. Do something you love, you enjoy. There'll always be work out there for you.
Absolutely. I completely agree on that. You know, here in Tel Aviv, in Tao International, we have this term we call Taoism, which describes your unique experience. So, what is your definition for Taoism?
Well, Tao is really my second home, maybe my first home, because from my undergraduate degree, I was here as a student from undergraduate and then graduate degree, and eventually came back as a professor and the head of school, geophysics, the head of the Porter School, the head of the Climate Center. So it's kind of been part of my life from my university degree. So basically 40 years I've been at Tel Aviv University from a student from the beginning. And on top of that, I met my wife here while she was a student in the law school. So Tao has also given me a family, a professional family, my personal family. I met my wife here. Some of my kids were born here. Some were born overseas when we were doing studies there. So it's really my home away from home, Tel Aviv University. So I have personal contacts to Tel Aviv and obviously academic. So I think that's the meaning of Tao for me.
Okay. Thank you very much, Professor Colin.
You're welcome.
And this was very enlightening and eye-opening. And yeah, thank you for your time.
You're welcome. Thank you.